Hi students, welcome to today's class. In today's class we are going to see about non-ferrous metal, and this non-ferrous metal is divided into copper, lead, tin, zinc, aluminium. Let's see our first topic, copper, under non-ferrous metal. Let's see what is non-ferrous metals. Metals without iron are called non-ferrous metals. Example: copper, aluminium, zinc, lead and tin. Copper and its alloys. Let's see the objectives of this topic. At the end of this lesson you shall be able to state the properties and uses of copper and its alloys. Copper. This is extracted from its ores, malachite, which contains about 55% copper, and pyrites, which contains about 32% copper. Let's see the copper properties. It is reddish in color. The structure when fractured is granular, but when forged or rolled it is fibrous. It is very malleable and ductile and can be made into sheets or wires. It is a conductor of electricity. Copper is extensively used as electrical cables and parts of electrical apparatus which conduct electric current. Copper is a good conductor of heat and also highly resistant to corrosion. For this reason it is used for boiler fire boxes, water heating apparatus, water pipes and vessels in brewery and chemical plants. Also used for making soldering iron. The melting temperature of copper is 1083 degrees Celsius. The tensile strength of copper can be increased by hammering or rolling. Copper alloy. This copper alloy is divided into brass and bronze. Let's see what is brass and its properties. It is an alloy of copper and zinc. The color of brass depends on the percentage of the alloying elements. The color is yellow or light yellow, or nearly white. It can be easily machined. Brass is also corrosion resistant. Let's see the application of brass. Brass is widely used for making motor car radiator core and water taps, etc. It is also used in gas welding for hard soldering brushing. The melting point of brass ranges from 880 to 930 degrees Celsius. Brushes of different composition are made for various applications. Let's see about cartridge brass. In cartridge brass copper and zinc content is 70 to 30% respectively. Properties and uses. It is the most ductile of the copper-zinc alloys. It is widely used in sheet metal pressing for severe deep drawing operations. Originally it is developed for making cartridge cases. Standard brass. In standard brass copper and zinc content is 65 to 35% respectively. Properties and uses. It is cheaper than cartridge brass and less ductile. It is suitable for most engineering processes. Basic brass. In basic brass copper and zinc content is 63 to 37% respectively. Properties and uses. It is the cheapest of the cold working brushes. It lacks ductility and is only capable of withstanding simple forming operations. MUNTZ metal. In MUNTZ metal copper is 60% and zinc content is 40%. Properties and uses. It is not suitable for cold working, but suitable for hot working. It is relatively cheap due to its high zinc content. It is widely used for extrusion and hot stamping processes. Free-cutting brass. In free-cutting brass copper content is 58%, zinc is 39%, lead is 3%. Properties and uses. It is not suitable for cold working but excellent for hot working, and high-speed machining of low-strength components. Let's see about Admiralty brass. Copper is 70%, zinc is 29%, and tin is 1% in Admiralty brass. Properties and uses. This is virtually cartridge brass plus a little tin to prevent corrosion in the presence of salt water. Naval brass. In naval brass copper is 62%, zinc is 37% and 1% of tin. Properties and uses. This is virtually MUNTZ metal, plus a little tin to prevent corrosion, in the presence of salt water. Gilding metal. Gilding metal contains copper 95% and zinc is 5%. Properties and uses. It is used for jewelry. Let's see about bronze. Bronze is basically an alloy of copper and tin. Its color ranges from red to yellow. The melting point of bronze is about 1005 degrees Celsius. It is harder than brass. It can be easily machined with sharp tools. The chip produced is granular. Special bronze alloys are used as brushing rods. Bronze of different compositions are available for various applications. Low tin bronze. In low tin bronze, copper is 96%, phosphorus is 0.1 to 0.25% and tin is 3.9 to 3.75%. Let's see about low tin bronze properties and uses. This alloy can be severely cold worked to harden it so that it can be used for springs, where good elastic properties must be combined with corrosion resistance, fatigue resistance and electrical conductivity. Example: contact blades. Let's see about drawing phosphor or bronze. In drawing phosphor, copper is 94%, phosphorus is 0.1 to 0.5% and 5.9 to 5.5% of tin. Properties and uses. This alloy is used for turned components, requiring strength and corrosion resistance, such as valve spindles. Cast phosphor or bronze. In cast phosphor, copper content is 89.75 to 89.97%, phosphorus is 0.03 to 0.25% and 10% of tin. Properties and uses. It is usually cast into rods and tubes for making bearing bushes and worm wheels. It has excellent bronze anti-friction properties. Admirality gunmetal. In this alloy metal, copper is 88%, zinc is 2% and 10% of tin. Properties and uses. This alloy is suitable for sand casting where fine-grained, pressure-tight components such as pump and valve bodies are required. Let's see about leaded gunmetal, free cutting. Copper 85%, 5% zinc, 5% lead, and 5% is tin. Properties and uses. Also known as red brass, this alloy is used for the same purposes as standard Admiralty gunmetal. It is rather less strong, but has improved toughness and machining properties. Let's test our knowledge we gained from our today's topic. Try to answer the following question. Which of the following two metals basically bronze alloy is made up of? Option A. Copper and tin. Option B. Iron and tin. Option C. Copper and zinc. Option D. Copper and iron. Your time starts now. I think you are right. The correct answer is option A. Copper and tin. Thus we came to the end of our today's session, and in our today's session, we covered copper topic under non-ferrous metal. And we see our remaining topics in our next session of video. Thank you. For queries, visit www.nimelearningonline.in/moodle.